explode? You missed it. It was all like fizzing and everything.
Yeah, keep in mind that it's solid carbon dioxide. Carbon dioxide is normally a gas, so it has to be extremely cold to become a solid. So right now, you've got an extremely cold solid sitting in a relatively warm liquid. That warm liquid is now losing energy to the cold solid, okay? When we put ice in our drinks, you think of the ice cooling down the drink, but in reality, the drink is warming up the ice. That's really what's happening. The liquid is transferring its energy to the ice, and that's what's happening here. Except instead of ice, which is frozen water, we've got dry ice, which is frozen carbon dioxide. Okay? How are my temperature readings going on the ice cream?
-7.7.
It's -7.7?
Wait, that's not even ready yet.
Well, I'm just saying.
Well, I was just asking what it is right now. Okay? Yeah, keep taking the temperature once every minute, okay? And then we're going to graph how the temperature changes over time. You're going to see how it plateaus.
What are you guys going to do with the flour?
The flour, one of these flours is in this ice box with the dry ice. The dry ice is extremely cold, so it's going to do something to the flour. I'm not going to tell you what just yet. You'll see. Huh?
Oh, is it going to kill it?
Well, I'd imagine it will kill it with some time, yeah. But it's going to be, well, obviously anything that's alive has water inside it. So yeah, exactly. It's going to freeze the water inside the cells of the flour. Inside of flour, inside anything that's living, you've got cells. Your cells have cytoplasm. Cytoplasm is the liquidy stuff inside the cell. It's mostly water. So just like our own tissue, that flour, if it's cold enough, it's going to freeze solid. And that's what eventually is going to happen. All right, so we've got the flour freezing, we've got our root beer getting carbonated, and we've got our ice cream churning. What about our cakes?
They're baking.
The cakes are in the oven, they're baking? All right, and how long is this going to take to bake this?
The timer's set. We've got it set for 35 minutes. It's
Okay.
going to be really, really close. What period do you guys have, Miss Butler?
I am
All right. It may end up that you're eating your treats in her face. All right, that may be how it works out.
Are you going to open it?
No, I'm not going to open it, but if you draw your fingers across the bottom here,
Sweating.
well, you can see that there's a whole lot of moisture. I mean, just look at my hands. There's all kinds of moisture on the outside.
Did spill some root beer on it.
Well, I mean, some of it's root beer. Very good, Kari. But a lot of this is condensation. So where is this water coming from?
The dry ice.
Now it's not coming from the dry ice. Dry ice is locked inside here. And remember, Kari, dry ice is called dry because Kari, dry ice is dry because it skips a liquid phase. It has no liquid phase. So this can't be coming from the dry ice because it's a liquid. Okay? So this is obviously water, but where's it coming from? It's not coming from the root beer. The root beer is inside.
The air.
Yeah, because this
It
is
comes from
making
the
out.
humidity. Exactly right. And the humidity, Melanie, just be careful with that because you're going to if you pull too hard, you'll rip the wire out. Thank you. So the humidity in the air is just basically, humidity is a measurement of how much water is in the air. Everybody understands that? So if they say the humidity level is 80%, that means that the air that we're breathing right now is 80% saturated with water. Remember we talked about saturated solutions? Well, the air that we breathe is also a solution. It's a mixture of nitrogen, oxygen, carbon dioxide, and water vapor. Humidity is a measurement of how much water vapor is in the air. And this water that's building up on the outside is the water that's in the air.
Are you going to drink it?
Huh?
Are you going to drink it?
Eventually we'll drink it, yeah. As soon as all the dry ice is gone and it's carbonated, we'll drink it, yeah. Now, this...
Oh my gosh.
Actually, yeah, you can see that some of the humidity is actually frozen to the bottom of this because it's so cold. So this is
Oh my god.
this is ice
That's so weird.
that was water in the air. But why is the water sticking to this? because it's cold. Exactly. Now,
You should drink some.
we will drink some.
No, you should.
Oh, I should drink some right now? No, I'm not going to open that because you can feel.
No, this.
Yeah, but Kari, understand that there's a great deal of pressure in here because if you see, it's forming bubbles. It's a gas is coming out. Okay.
I think we have to try it out.
You want me to try it out now?
Yes.
Unless you want me to do it.
Yeah, let me have some goggles and let me. If there's an apron available, because I have a feeling as soon as I open this spigot, it's going to come shooting out because it's under pressure.
Come on, Mr. P, I'll do it.
Okay, I don't like this color. I want to see this. Oh my gosh, I'm drinking. See, Miss James did drink some.
No, I'm afraid once I get to drink it.
I was offering. I would have done it.
Not bad.
Yeah, healthy.
I want to try it.
It's not bad. It needs a little bit more carbonation. So if we let
Daddy wants to
it
try
sit for a little bit longer and let all that carbon dioxide turn into a gas, it's going to get more carbonated.
But I want to try it after you.
Okay, you're good, Fatty.
Now, how is the root beer?
It's actually good.
How is the root beer becoming carbonated?
If you're not going to finish it,
From the dry ice. The dry ice is going from solid to gas, sublimation, and some of that gas is doing what? How is that gas getting into the root beer? Well, it's not melting because remember it's dry ice. It doesn't melt because the melting is going to a liquid, and dry ice goes from solid to gas. It's sublimation, okay, which produces the gas.
right on top.
But remember when I was talking about the oceans, oceans have oxygen dissolved in it. All right, ocean water has oxygen dissolved in it. So would it stand to reason that this root beer, some of the carbon dioxide is dissolving into the root
Hey, what
beer?
is it?
Does that make sense?
5.4.
Yes, no? Okay. Keep in mind that there's a lot of pressure in here.
No, it goes up
As a matter of fact, if you try to squeeze on it, you can feel that there's a great deal of pressure in here. More pressure means more gas is dissolving into the liquid, which means this liquid is becoming super saturated with carbon dioxide.